Hi everyone, welcome to my video channel. Do you like to make coffee or tea at home? If you do, you probably need to use a kettle to boil water. I like to use an electric kettle because it heats up water fast and switches off automatically when the water is boiling. If you're curious about how an electric kettle works, then follow me. Let's take a closer look. In this video, you will see some basic concepts in physics. But don't worry, you don't need to know the theory behind them. Here is a clip of the electric kettle that I use to make tea at home. Do you ever wonder, how does an electric kettle make water boiling? And how does it know when to switch off? First, let's look at how does an electric kettle heat up water. When you plug the kettle into an electronic outlet, a large electric current flows into the heating element. Heating element is the component of a heater that transforms electricity into heat. In our case, the heating element is a coil of thick metal at the bottom of the kettle base. The element's resistance turns the electrical energy into heat. In other words, the heating element gets hot. When you put the kettle body on top of the base, the heat passes from the heating element to the metal body. Since the metal body is in direct contact with the water, the heat then passes to the water by conduction and rapidly warms up the water. The next question is, how does the kettle disconnect when water is boiling? Obviously, the first idea that often comes to our mind is to use a temperature sensor. Because we think a temperature sensor can sense the temperature of the water, and the water is boiling at 100 degrees centigrade. With some electronics, it will turn off the electricity when the water is boiling. But there's a problem of accuracy here with this idea. Because the temperature sensor will have some error to it, it will be impossible to get a temperature sensor exactly for 100 degrees centigrade. So maybe it will trigger at 99.9 degrees centigrade. In this case, the water will not boil because the electricity will turn off before the water reaches 100 degrees centigrade. On the other hand, if the error will be on the high side, say 100.1 degrees centigrade is the trigger point, then the water will not stop boiling because the kettle will never turn off. So this is not a very good idea in terms of accuracy. In addition, there's another severe problem. Water indeed boils at 100 degrees centigrade. This will be pure water. That's distilled water with no salt in it and at sea level. So if we go up to the mountain, the water will boil at a temperature that's lower than 100 degrees centigrade. And if we go down, below the sea level, say the Dead Sea area, the water will boil at 100.5 degrees centigrade. So even if we are going to have a very accurate temperature sensor, it will be useless because it will only work at one spot at sea level, not to mention that the fact weather is also changing the atmospheric pressure. So the temperature sensor is not a very good idea. Another idea, which is in fact used in the popular kettle that we have around us, to use the vapor. The idea is that when the water is boiling, the vapor is then coming out and the steam is coming out. This is an indication that water is boiling. In this case, you won't need to worry about what exactly is the temperature of water. You just look at it at the instant that the vapor is starting to come off. This is indeed the idea of the electronic kettle that we are using today. Before going into the structure of the vapor idea, let's look at an important structure about bimetal. We have two pieces of metal. One is copper and the other is iron. When we warm up these two pieces, they expand. Each metal has a different expansion with the same temperature. Therefore, if we're going to put these two pieces together, like this, and heat this assembly, what will happen is that this piece of bimetal will actually bend. The reason is that if one piece is becoming longer than the other one, then this assembly structure is comparable to the other one, because one arc is longer than the other one, just like when they were separated pieces. Now we understand that bimetal will bend after the increase of its temperature. That's the idea applied here in the electric kettle. Next, let's see the vapor idea structure. We have the body of the kettle, we have the water, and we have a tube coming from inside down to the switch bottom area. Here I'm exaggerating the length of the tube so we can see it clear how the switch and the bimetal trigger work. The red line represents the electric heater, which is connected to the main through the contact here. The blue line represents the power line. Now the blue contact here is actually connected to the small lever here, which is in turn is attached to this bimetal. So the idea is that when the water is boiling, the vapor will penetrate through this tube, go down, the vapor's heat will pass on this bimetal, then the bimetal assembly will bend and move the lever, and this will open the switch. So let's have a look at it. Here it is. This is the vapor, comes in, pumps up the bimetal, brings up this piece, which disconnect the circuit ring. We have a latch here. So once it's moved, then it will latch and will not return even if the bimetal is cooling off. Like this. So let's have a look at it again. Here it is again, when the water and the bimetal is cold. Here it is, when we have the vapor bending the bimetal. Since we rely on the steam of the vapor going into the tube, if the kettle is open without a lid covering the vapor, then the steam will go up. There will not be enough pressure for it to go into the tube, so the bimetal will not warm up and it will not disconnect. I've tested this with my kettle. Let's look at how it works. First, I turn the switch on to heat up the water. Then I open the lid. We can see the water is boiling. The vapor is coming out, but the switch is not disconnected. Now I close the lid. We can see the switch is disconnected right away. Now we can make delicious tea with hot water. I hope you enjoyed this video. Thanks for watching.